Okay, so a very quick introduction to programming with no actual programming. Go. Next. Next is what do you call a robot with no software?
Brick. A very expensive hunk of metal.
Paperweight.
Brick?
Well, it's a fine piece of industrial art, but it's not very fun. What's really fun is when you can make robots that do this. So you saw this on an earlier presentation. This is our bot from 2 years back, slamming basketballs into a, well, autonomous, but our robots move really nicely and really fast. Yes. And we use a lot of software to make that happen. So how? Well, the software we use, people have experience with like radio-controlled cars. You've seen those? Yeah. You can think of this at one level as a great big radio-controlled car. And the software exists to translate the driver's intention into motors turning on and off, switches and sensors actuating to drive this thing around so that we can move down to the far end of the court and score. Software also works in autonomous mode where this thing scores by itself for the first 15 or 30 seconds of the competition. Next. So controlling it is about translating intention into action. You've got to look at various points at all the motors and sensors and things in here. It's the job of software to translate somebody turning the steering wheel and somebody pushing a button into things going up and down, motors spinning up at the right speed, and the right things happening and also the wrong things not happening. So we use a lot of control theory. So if you're a math junkie at some point, control theory can kind of be a challenge, right?
It's fun.
It's fun, yeah. So, go. So as I said, we want to preserve the wrong things from happening. First is very safety conscious. We are very safety conscious. And we just, things like this are right out in a competition. So, next. So we also, when this thing doesn't behave the way we want it to, we need to figure out why. And sometimes that's not as easy as just sort of poking in there looking for a part that's on fire. Something didn't happen because something's gotten loose, or so we record a lot of information as we go. Writing log files out onto. There's a second computer with a solid state drive on there that we'll write logs out onto that we can dig back into to do sort of forensic analysis. It's kind of CSI for robots. It's this signal happened, we expected this to happen, it didn't. That narrows the search down and can help us find and resolve problems pretty quickly. So how do we do this? Well, the season is 6 weeks, but since we're building a second robot, we have time to perfect the software that's going to drive this thing right up until the first competition and beyond. So FIRST provides us with a starting set of tools. They provide things like the wireless access point. There's a computer in here called a C-RIO, and a bunch of other stuff that all the teams get. Now, we go beyond that here. And the rules for how this thing hooks together. So here, it's a little hard to see here, but you can see it on the back of this robot. There's a wireless access point that is it's connected to the judging station. All of the signals from the drivers go through the judging station, the field management system, across this wireless link into the robot. Now, the reason for that, the reason that we don't control the robot directly is safety. If something goes amok, we want to be able to stop it before it destroys Tokyo, okay, or little houses. So, because we're competing at a fairly high level, we go beyond what FIRST provides us. The rules allow us to add our own compute power to this, as long as we don't sacrifice the ability for them to have a kill switch. So we've extended that by offloading a lot of our processing onto a combination of a very smart gyro board that has a processor on it, and a thing called an Intel Atom, just an Intel chip on a very small computer embedded down in here. And that gives us the potential of doing a lot more work than you can ever hope to get the stock computer, which is pretty old, to handle. Next. So our development environment. If you're going to be working on the robot, or anything else, you'll get a subversion account from Mr. Shu. All the code that runs on the bot gets checked into subversion. And they're all done, or have traditionally been done, on fairly identically configured development environments. Now, the reason that we want everything done on very similarly or identically configured laptops is it keeps us out of this problem that you'll run into later in life of what works on my computer, why doesn't it work on that computer? So we're have fairly tight controls over what goes on those laptops. The code that runs on the robot is in C++. We also do some coding in Python for the scouting system. And we have a website with a lot of documentation that it's worth your time learning to search to find information. And we have mentors. I help with the scouting system. Various people help with Austin, who's in the other room, helps out with code that goes on the robot. Yes. And if you set out to write code for the robot, we do ask that you follow some development practices. Now, if you go out into industry after you graduate from college, or even as internships during college, you'll find that you'll be exposed to certain software processes that are really there to ensure a good outcome. And we follow a few of those here. The code that goes on the robot, if it's a high-value code, we have tried to do code reviews on that. We have a code review tool set up to help with that. There's some standards we probably should follow a little bit better. But we build things at a fairly high level of sophistication with fairly good practices that you'll learn along the way if you want to program this thing. And we do that because we don't want to find ourselves fighting off problems that we could have avoided by having sloppy process. So, identical development environments. If you join us in programming this thing, and you're working on one of our computers, the general rule is don't install anything without going through Mr. Shu, because we want to make sure. Right.
Yes.
Yeah.
So I just raised my hand.
Okay, great. Don't install anything, no games, nothing else, because it's really easy to accidentally foul up a development environment by you get a virus or something, and it burns up a lot of our time trying to recover from that could be spent on programming a robot. So, yeah. So, 2 sets of eyes on changes. Getting involved in coding this thing or coding the scouting system is a great way to learn about programming, to boost your programming skills. And Google follows all these practices. So, next. We also do software for simulations. 2 years ago, Daniel was here earlier. Daniel built this simulation of the arena. And we've been able to employ simulation, next slide, to do things like predict what the robot's going to see. Here, from 2 years back, we're shining an LED ring up onto some retro-reflective material. And when FIRST announces the details of the competition, they give us the dimensions of the arena, like down to the 1/4 inch. We were able to build a model saying that from what we know about how we're going to build the robot and how the webcam's pointed, we should be seeing this. And when we actually got the robot to NASA and were able to take pictures from the webcam we had mounted on it, this is what we saw. So we could simulate things. We have the capability of simulating things to a pretty high degree, and that gives us a leg up in planning how we're going to shoot, where we can shoot from, so many things like that. Website. If you are not interested so much in programming, but are interested in web design, there's a lot of opportunities for you to get involved in extending our website, posting things, helping arrange information out there. A lot of stuff to do there that's very valuable. Now, scouting software. You heard from the scouting team. Scouting gathers a lot of information. And next slide. What it looks like is during competition, while we're watching what all these robots are doing, people are taking notes that get fed into a scouting system. That's Marie typing away madly. She practically burned out her fingers during outgames this way. And we use that information to help us strategize and help us do alliance selections. Next slide. So this last year's system, we're actually able to feed that information in sorted various different ways to give us a fairly quick assessment of how are the teams that we're going up against, how's their driving, how's their shooting, and I think this ranking sheet was used for as part of alliance selection. This thing runs on a separate schedule. Again, it's Python. It's running on a laptop. If C++ is a little scary for you, learning to work on this, and I'll be teaching some Python along the way, is a good opportunity to sort of contribute to the team and boost your programming skills. We're in this thing to win, but even just fielding a robot is a lot of fun, and software helps us do that. So, a couple words of advice on this thing. It's the programming on the robot itself is complicated enough that if you're coming in as a freshman to the team and don't have much programming experience, it's a little much to expect that you're going to hop right in and have code running on the robot your first year here. But our code is out of the Subversion repository. It's there to read. It's there to learn with, and it may take you a year or two if you don't have prior experience to get up to the point where you can start to get code out of the robot. But it's a very worthwhile thing to do. Motivated students go farther. If you've got the motivation to dig in and ask questions and read what's there and experiment and maybe try out some code on the practice spot, this is a great opportunity to actually have some code running that causes big things to move, and that's a heck of a lot of fun. So, questions on this?
Didn't Brian program the robot as a freshman?
Brian, didn't he also have a lot of experience coming in?
Yes.
FLL, and so he wasn't starting cold.
Right. He wasn't starting cold, but he. The point of that is freshmen program the robot if they are so skilled.
If they are so skilled. So hard work here is rewarded.
Yes, richly.
Yeah. So, thank you.